set. Thank you. All right, thank you. Anybody else still working? Is that it? Okay. All right, that's it? Everyone's turned in? All right, shall we discuss this? Should be able to go through this pretty quick. So please be on time. Please be on time. You might miss a quiz. All right, so if you miss a quiz, I'll give you one miss, that's it. After that, you just take zeros, all right? So please be here on time. This first problem, we're asked for some limits. So the first limit is, what's the limit as x approaches -3, and I had a little negative sign up on the top. So coming into -3 from the left, the answer should be 1. The next, part B, said the limit as x approaches -3 from the right. So we're approaching -3 from the right. That's approaching 3. For part C, I ask, what is f of -3? So that's the algebra question. What's the value of the function at -3? That's where the solid dot is. So that's 3. Then I asked for the limit as x approaches 0, just 0. I just said, what's the limit? I didn't tell you left or right, which means you have to check both sides. And so here's x is 0. As you come in from the left, it dives down to -infinity. And as you come from the right, dives down to -infinity. So it's the same thing from both sides. Your answer should be -infinity. Yeah? Let's see. F of 0. Ask, what's the value of the function at 0? And you don't see any dots there. So we would say undefined, right? Undefined. Part F, what's the limit as x approaches 2? And I don't say left or right, which means you have to check both sides. And so as you approach 2 from the left and from the right, you're headed to the same point or same value, and that's 2. And then finally, what's f of 2? The value of the function at 2 is 1. So that's the first one. Or that's, yeah, the first problem. Now the next one was this limit here. Okay, the limit over there. So if you plug in 5 on top and bottom, you get 0 over 0. So we have to do some algebra. So the algebra on that, I told you I was going to try and make it an easy one. I hope that you agree that that's easy algebra. Difference of squares on top, right? And then once you do that, then you're allowed to cancel those out so long as you promise me that x will never be 5. But because we're taking a limit, that's okay. Now we let x go to 5, and 5 plus 5 is 10. So 10, there you go. That's it. So I hope that first quiz was kind of like a nice, clean quiz for you. I don't intend on trying to make like quizzes super, super hard. It's just, do you understand the basic ideas from the previous class? All right? Any questions? Yes?
So when you said undefined,
yes.
it's undefined, not, it does not exist.
So I want you to reserve undefined for when we're talking about the value of a function at a point, and use does not exist when you're talking about limits. Okay. Now, that could be debated, all right? There's kind of different thoughts on that. I like to distinguish the two. Some people would not count it wrong if you use does not exist. And for the first quiz, I won't take off. If you put does not exist instead of undefined, I'll probably circle it and put undefined but not penalize you for it. All right? All right, so that's it. We're going to continue. Make sure I don't go past 4:30 today. I felt terrible about that. All right, so here's our calendar. Where's my sword? There it is. So our calendar, we were supposed to cover 1.3, 1.4 on Tuesday. We did not quite finish 1.4, so we've got more to do here. And then we're going to do 1.5, 1.6, but we're actually going to reverse the order, and we're going to do 1.6 before we do 1.5. And you'll see, once we do it, why it really doesn't matter what order we go in for those sections. It actually makes a little more sense to me to do the 1.6 before the 1.5. So let's finish up the 1.4 now. Were there any other questions over homework or anything? Any problems on the homework that you want me to address? Yes?
Question 24.
Question 24. Where's my book? There it is.
And 27.
So you're talking about from 1.4?
Yes.
Okay. 20, what did you say, 20 what?
24.
Was that 1 over t minus 1 over t squared plus 1, that one?
Yes.
Limit t goes to 0? Yeah, be happy to do that one. So limit is number 24. So limit t goes to 0, 1 over t, parenthesis, minus 1 over t squared plus 1.
Isn't it T
Wait,
plus T?
yeah, t squared plus t, but I'm trying to move this thing out of the way. There we go. All right. There it is. So if we let t go to 0, we're going to have 1 over 0, which is undefined, right? And then we have 1 over 0 again, which is undefined. And so we've got some problems here, right? So I'm going to try and do some algebra, something, right? You've got to try something. So the algebra that I'm going to do is I'm going to try and put these two fractions together, get a common denominator between the two. So think of it this way. If we're looking at that expression, before I take the limit, please realize that on the fraction on the right, you could factor a t out, like that, right? I have a common factor of a t in both of these, so I can pull that t out. And what that helps me see is that to get a common denominator, all I need to do, they both have a t, all I need is a t plus 1 in both of them. So I'm just going to multiply this fraction by 1, right? But the one that I'm going to use is t plus 1 over t plus 1. And if I do that, then they would have the same denominators. So when I do this multiplication, this times 1 is itself. And then I have minus the 1 up here, and then all over the common denominator, which was t over t plus 1. So that's just combining. And this 1 and negative 1 cancel out, so we get t over t plus 1. And now I can get rid of those t's. So I can get rid of the t here, and that would leave me with a 1 on top and then a t plus 1 on the bottom. So all of that is just algebra. Pardon? Is that okay? Okay. So now I'm going to come back over here and I'm going to say, okay, this is equal to the limit as t goes to 0 of 1 over t plus 1. And now if I let t go to 0, I no longer have a problem. I just get 1 over 0 plus 1, 1 over 1 is 1. Okay. So when you see fractions like that, right, and you have problems, a lot of times putting the fractions together will help. Not every time, but I mean, we got to try something, right? Okay, the other one was what? 20 what? 27. Okay.
I got a different answer than the book.
You got a different answer than the book. All right, so we've got limit, h goes to 0, x plus h. I thought we did this one. Did we not do this one? Maybe not. We did something similar, didn't we? Which one did we do? Hold on. Wait a minute. Didn't we do that? We did that in class, did we? We did that in class. Yeah. Well, you can do this. You can do this problem two different ways. You can look at this as being a difference of cubes and factor it, or you can do what I did in class, which was to take x plus h and multiply it 3 times and expand it and then cancel things out. Both ways work. So, who asked that question? Do you want me to? I mean, we did it. I don't.
I think I may have had.
Did you do difference of cubes, or did you actually multiply this out?
I multiplied it out.
Did you get x cubed plus 3x squared h plus? We didn't do that one?
Okay.
Okay, well, it was in my notes, so I thought we had done it. I'm sorry. We did not? Sometimes I don't do every single problem. We have debate, and we have a debate now. I remember expanding x plus h cubed. Okay, you expand it. I'm just going to go super fast because it's in the notes. Limit h goes to 0. Expanding that without showing any work, x cubed plus 3x squared h plus 3xh squared plus h cubed. That's what you get when you multiply that out. Minus the x cubed that's here, all over the h. That's your first step. Then that gets killed off. And everything that remains has one factor of h in it. Right, that has an h. Yeah, because I remember I pulled too many h's? Yeah, I remember messing that one up. So you pull an h out, you get 3x squared plus 3xh plus h squared. If you pull that, and then the h's go.
And then you cancel out.
Yeah, now you let h go to 0, which makes this and this go away. See, don't forget you have to take a limit, right? And so all you're left with there is 3x squared. Yeah? All right. 28. Yes. That's a good one. This is my last one, though. If you want me to do more, you can come in my office, or we can meet on Zoom this weekend or something. So for 28, limit h goes to 0. And also, don't forget I have video solutions of me solving homework problems, even though I don't do every single one of them, right? There we go. So if we check right now, if h goes to 0, let's see what happens. If h goes to 0, that goes away, and this just turns into x squared. So on the top, we have 1 over x squared minus 1 over x squared again. All over h goes to 0, the bottom goes to 0. The top, 1 over x squared minus 1 over x squared is 0. So we do get 0 over 0 here. So I'm going to do some algebra. And I told you a second ago and last class that whenever you have fractions, try and put them together. Get common denominators. So I'm going to get a common denominator between these two. I'll do that over here, scratch work. I'll come back over there in a second. I'm just working with that top. So to get a common denominator here, unfortunately, we can't do anything to turn this into that, and we can't turn this into that. So we actually need to include an x squared on the top and bottom here, and then we need an x squared on the top and bottom here. I'm sorry, not x squared, x plus h squared over here. That's what we have to do. So now they'll both have the same denominator, so I'm just going to do x squared times 1. So my new numerator will be x squared, then minus, see I'm combining them together, 1 times that, all over the common denominator, which was the x squared times x plus h, that squared. Is that all right? Okay. Now, let's just put it back over here, just so we have it. X squared minus x plus h, that thing squared, all over x squared times x plus h squared, but all of that over longer division bar there, over h. What I'm hoping for at some point is for this h to go away, to cancel out. That's what I'm hoping for. And obviously I can't cancel it with this h because it's trapped inside the parenthesis and everything. So I'm going to see if I can't somehow release it. To do that, I'm going to FOIL this out. I'm going to do x plus h times x plus h, multiply those two together. I'll continue over here with that work, and then I'll come back to this. So if I were to continue with this, it would be x squared minus, now this you have to do, multiply that out, x plus h times itself. FOIL, combine like terms. If you do that, you'll get x squared plus 2xh plus h squared. I'm not showing that work, but you're subtracting it, which means you have to have parentheses around it so that the negative will distribute through. Then all of that divided by that common denominator. And good things are about to happen, right? Because if you distribute this negative through, you'll now get x squared minus x squared, those are going to go away, minus 2xh minus h squared, all over your common denominator, like that. Still good? Yes? You asked about it, right? Okay. So these go away. And so now here's where we are. Limit h goes to 0. I have a negative 2xh minus h squared on top of the common denominator. X squared times x plus h, that quantity squared, all over long division bar h. Shoot. Okay, so do y'all see it? I want that h to go away on the bottom. What am I going to need to do? Oh, you can flip. You can flip, yes. Do y'all see these both have an h right there? So can't I pull a single factor of h out of that? And that should cancel. Let's see. Let me go ahead and do it right up here. Limit h goes to 0. I'm pulling an h out of the top, so h comes out. I still have negative 2x here, and then minus, I still have one factor of h there. All over the denominator, x squared times x plus h, that quantity squared. And then over h, right, over h. But I'm going to do something I did last class. Remember, that's like this. So I have a fraction over a fraction. Fraction over a fraction, right? Which means I can take this fraction and flip it and bring it up as multiplication. I'm going to do that on this step. So instead of doing over h, I'm going to say times what? 1 over h. I think that just helps people see that these h's are now going to go away. See them? They're going to go. And that's what I was hoping for, is to make that h go away. And so I'm almost done. Equals limit h goes to 0. Negative 2x plus, no, minus h over x squared times x plus h, that quantity squared. Everything else went away. Now let h go to 0, right? Let h go to 0. Do I have any questions? Everyone's good? H is going to 0, so I'm no longer going to write the limit. On top, I just get negative 2x. On the bottom, I have x squared. And then this h goes to 0, so I have x again here, but then squared, so another x squared. So this becomes negative 2x over x to the 4th. And then I can just get one factor of x to cancel out. So I get negative 2 over x cubed. There we go. That's my answer. So lots of algebra, right? Lots of algebra in there. All right, we're moving on. If you have more questions, please get in touch with me. Remember, on the syllabus, I have my cell phone number. Feel free to text me over the weekend, whenever. I will let you know if I'm busy, but if I'm not, I'm happy to meet you online in my Zoom office hours, and I can help you get through one of the problems or a few of them. So what are we talking about now? We're still in the same section, right? So far we've seen that when we do these limits, if we get 0 over 0, right, it's bad. I've said this. I want you to consider these two limits. Let's look at these. Limit x goes to 0 of sine x over x. Let's look at that one. I have another one over here I want you to look at. Limit x goes to 0 of cosine x minus 1 over x. These are two very famous, not famous, but very important limits in calculus. They come up in different places, and so it's actually pretty good for us to be able to know what these limits are. So now we got to go back to pre-cal for a minute. I'm going to let x go to 0. We need to know what sine of 0 is, right? Sine of 0. So that means go to the angle 0 on the unit circle. Go out and give me the y coordinate, because we're talking about sine. So what's the y coordinate out there? 0, right? 0. So the top is headed to 0. The bottom is headed to, well, x is going to 0. So 0, right? So we have 0 over 0. This is bad. Similarly, on this problem, x goes to 0. Cosine of 0, same thing. Angle is 0. Go out there, get the x coordinate this time. That's 1. So you get 1 minus 1 on top, which is 0. And on the bottom, you get 0. So both of these limits give you 0 over 0, don't they? So we're supposed to do some algebra or some trick at this point. So let's focus our attention on this one. There's no algebra that you're going to be able to do, right? Because everything we've done has been like, okay, we get like two fractions, we put them together, or we do factoring, right? Difference of squares, like the quiz problem, or conjugate. We did conjugate last time. I don't see any square roots. There's no factoring I can do here. There's absolutely no algebra that I have in my toolbox that allows me to do anything with this. And you can't do this, right? You can't do this, right? You can't do that. Why? Why?
It's inside the sign.
Yeah, so when you write sine x, you really mean sine of x, right? And this is not multiplication. This is not, I mean, what is sin by itself, right? Sin, just the letters sin, means nothing. The sine function has to have an argument, something being plugged into it. And so these do not cancel, all right? So you're not allowed to do that. So we don't know, okay? Right now we are stuck, okay? We are stuck right here. We don't know what this is. And this one, same thing. There's no algebra we can do, all right? You're just going to have to trust me that we're stuck, okay? We're stuck on both of these, all right? So we could go graph it on Desmos, couldn't we? We go graph it. How about we graph the first one and just see what happens? What I'm going to do is I'm going to graph sine x over x, and we're going to look what happens to the graph as we go to 0. Just see what it looks like. Whoa, what the heck? Yeah, I'm totally messing this up. Okay. What does it look like is happening as I approach 0 from both sides? Looks like I'm headed to 1, right? Looks like I'm headed to 1 as I approach 0. Here's 0. Approach it from both sides, and you're headed to 1, right? And Desmos actually gives me no indication at all that there's a problem at 0, right? Like if we try and plug 0 in, you get 0 over 0, don't you? Desmos does not tell me that, and I've always hated this about Desmos or any graphing software. It's like, it's 2023. By now, there should be a hole there. It should show us there's a hole. If I drag it with my mouse, it'll give me the value, and watch what happens when I try and get to 0. Oh, I went past it. Come on. There it is. See that? Undefined. You see it put a hole there? Why couldn't it just do that from the beginning, right? I mean, by now, they should have figured this out. You agree? But we don't know that. So if you just look at it, you don't know there's a hole there. But there is. All right, so it looks like the answer is 1, doesn't it? Let's look at the other one while I've got it here. The other one was, it was cosine x minus 1, all of that over x. It's the blue one.
Is the minus 1 on the inside?
It's outside of the x. It's cosine x, whatever that is, then take away 1.
Okay.
So what does it look like to you? Coming from the left, coming from the right, where's it headed? To 0. Now we know at 0 it's what? Oh, there we go. Okay. Ah, shoot. Okay, you saw it, right? There it is, undefined. So again, the graph should have a hole in it, but we can't see it. So it looks like these limits exist, but there's no algebraic way for me to actually convince you of it. I have to convince you with the graphs. Now, you're going to have to just take these on faith for now. And then later on in this class, I'll be able to show why these are true, all right? Just right now, we don't have enough tools in our toolbox for me to convince you that these two limits are what they are. So, back to the notes. The notes say two very important limits. And I don't know why it looks like this. Let me evaluate the notebook again. I'm not sure why it's showing up like that. I don't like that at all. Let me not save that. Yeah, there we go. I'm not sure why that was looking like that, but so know these. It says know these limits. If you ever take the limit as x approaches 0 of sine of x over x, or if you flip it over, in both cases, your answer is 1. All right? Also, if you take the limit as x approaches 0 of cosine of x minus 1 over x, your answer is 0. Right? This one you cannot flip over. That one you can. Now, as good as these notes are, and this is what you'll see in the textbook, this is actually not the way that I like to teach this. I actually have something else I want you to look at. And when you see this for the first time, you're going to be like, what in the world? So here's the way I want you to think about this limit. What's happening is, and I'll bring the original one up so you can see them both. Notice on this first limit right here, we have sine of x over x, and the x is going to 0, right? Instead of looking at it as x, I want you to say what we have is sine of some junk. I don't care what it is. That's some junk, all right? And then it's over some junk. Now, this junk right here, they have to match exactly. So as long as these two junks match, so I say that right here, as long as the junk is exactly the same here and here, and the junk goes to 0. So as long as whatever's here and here goes to 0 and they look exactly the same, then your answer is going to be 1. And you can flip it over and it works the same way. Let's do an example of that and then I'll talk about the next one, all right? So how about something like this? Let's do the limit as x approaches, let's go with 2 of sine of x minus 2 over x minus 2. So you look at it for a second. You let x go to 2, that goes to 0, right? Let x go to 2, that goes to 0. Do we have sine of junk over junk?
Yes.
Yes. Do these junks match exactly? Yes. Do the junks go to 0? Yes. So the answer is 1.
1.
And that's it. You don't have to do any more work, right? The key is that you got to have sine of junk over junk. The junk has to match, and the junk has to go to 0. So if this limit was going to 4, let's say it was limit x goes to 4, then the answer would not be 1, because these aren't going to 0. They have to go to 0, and they have to match. I'll give you another example next to this one. Limit x goes to 2 again. Let's go sine of x minus 2 over x squared minus 4. Let x go to 0. Let x go to 2. That goes to 0, doesn't it? Okay, so I have sine of 0. On the bottom, 2 squared minus 4 is 0, right? But it's 0 on the bottom, yes? So they both go to 0, don't they? What's up here goes to 0. What's here goes to 0. But do they match? Are they exactly the same?
No.
They're not exactly the same. So I cannot say the answer is 1. Right? What I can do, though, is I can realize that the denominator is a difference of squares. So I can rewrite this as sine of x minus 2 over x plus 2x minus 2. I should tell you, I'm so sorry. I write my signs very quickly, and a lot of times it looks like an S and a W. That's actually S-I-N. Like that one's pretty good. But a lot of times I do it so fast I don't pick up my marker and it looks like an SW. So that's sine of x minus 2. I realize that the denominator is difference of squares. And now, do you all see that if I focus my attention on just this right here, that sign of junk over junk, the junk matches exactly and the junk goes to 0. Y'all see it?
Yes.
But I have to use a limit law from last class to do this. The limit law says that I am allowed to look at this as that times this. So all I'm doing there is I'm just kind of pulling apart those fractions into 2 fractions, right? Do y'all agree that this times this is the same exact thing? I would just go straight across, I get that. Across the bottom, I get that, right? The limit law says that if you take the limit and you have 2 things being multiplied, you can do the limit of each one separately. So what happens if I let, sorry, I don't know why I put infinity there. I have no idea why I put infinity. Sorry. Limits, x is going to 2, not infinity. So as x goes to 2, this goes to 1 over 2 plus 2. That goes to 1/4, right? So this goes to 1/4. 1/4 times, right, there's a multiplication there, times. Now this is the sign of the junk over the junk matches, the junk goes to 0, that goes to 1. So 1/4 times 1, 1/4, your answer is 1/4. Y'all see the difference between those 2 problems? Okay, no questions? I'm gonna give you.
Why is it equal to 1 when it's like junk, like when it's the same?
Oh, why? So this is the one I'm saying you have to take that on faith. I can show it to you later. I can prove it to you later. I can't prove it to you now. I tried to show you with the graph that it goes to 1, but other than that, I don't have an easy way of showing it to you. I mean, I could. If you really want to see it, you can come to my office. It'd take me about 45 minutes. There's a way to prove it geometrically. It's a beautiful proof. I'd love to go through it with anyone. I've offered that to my students like for years, and no one's ever come by and, but there's a beautiful geometric proof of it. But that's the best I could do at this point. Later, we will get this tool called L'Hopital's rule, and we'll be able to show it very quickly. It'll be almost instantaneous, but we just don't have that yet. So you just have to believe it, okay? Blindly accept it. Okay. All right, so I want to do another problem. How about this one? I'm going to leave that one up there because this one's going to be similar. That's a good question. Can we, right? So before we get to that point, let's just all agree that when x goes to 2, we get a 0 in here. We get a 0 down here, right?